Welcome guys. So in this video, let's talk about a little proof in set theory. So this theorem is called no universal set. So I have seen this proof many times, but I never like a rigorous write down. So this is also called the Russell paradox. So yeah, so Russell is like a famous mathematician and a philosopher I think it's in the 20th century. Okay, so the idea is that there's no universal set. So let's define a universal set and then improve it now. So universal sets means that if A is a set, so if A is a set, then A belongs to U. So this U is called, and U is called universal set. Okay, so the famous theorem is that universal sets cannot exist in the Zamenhof-Frankel-Cantor's set theory. So it's not. So the theorem is that there's no U in ZFC set theory. Okay, and the reason is that because there's a theorem in the set theory that you can assign which is a set. So for example, okay, so let's see the proof. So proof is like I can take a set called T, defined to be, let's say, X belongs to U, right? Because now you see if X is a set, right? So X can be, I can ask whether X belongs to U or not. Okay, so I can say X do not belong to X. Okay. So T exists, right, by ZFC. If U exists. So if any set belongs to a universal set, then X belongs to U. This statement makes sense. Also, this statement also makes sense, right? Because in the ZFC, guarantee that this statement makes sense. So T makes sense. So T exists by ZFC if U exists. Okay, I should add S. Okay, so now I can ask T be whether T belongs to T. Okay, so why I can ask this, right? Because any set. Okay, so let's say whether T belongs to T. So this is a question. Okay, so now if T belongs to T, then by definition T belongs to U, right? Because any set. So you see T is a subset of U, right? T is a subset of U because T take elements of subsets. T take an element of U. So T is a subset of U, right? So and the T is also set. T is also set, right? So must belongs to U, right? But if T belongs to T, and the T belongs to U, that means T do not belongs to T, right? By the definition of T, okay. So you see the same trick if T do not belongs to T, and then we also know that T belongs to U, right? So that means T belongs to itself, which none of it makes sense, right? If you see this statement. Okay, so this means that T cannot exist. Okay, so that means U cannot exist. Okay, so this is the universal, the famous proof of universal set. Okay, and another proof basically, let's maybe talk about another proof. Okay, so another proof uses the Cantor's theorem. So if you do not know Cantor's theorem, you can go back to my video channel, and maybe I think it's in the set theory channel list. And that means that if A is a non-empty set, then one must have the cardinality of the power set of A greater than A. Okay. So let's assume that if you have a this is obvious that if you have a universal set, right, then U must be a subset of 2 to a U, right? But 2 to a U can also in U because U is a universal set, right? But this will contradict to cardinality theorem because power set of U always has strictly larger cardinality of U, and then we know that U cannot be empty. Because I know that there is a non-empty set, so U cannot be non-empty. So the cardinality of the power set of U must be greater, strictly greater than U itself, but U also contains itself, so there's this is contradiction. Okay, so this is the famous to prove the idea of the there's no universal set in ZFC stats theory. So that's for my channel. I will see you guys in the next videos. Be sure to subscribe to my channel. Thanks.